Namaskaram everyone, welcome back to the episode 54 of the Master Anjal series, and in this one we are going to finally start the gas in C++. So we are going to set up the gameplay attributes, and in this one we are going to set up our health system. So if you haven't got your project into C++ migrated or converted or started, I highly recommend you check out this episode so that you know how to set up the Visual Studio, how you can convert or migrate your project. And once you are ready, you can directly start from this episode if you only want to focus on the gas. So without wasting any time, let's get started. Okay, so we are in the editor now. If you are following the series, then you are already aware that I have shown how you can convert and migrate the project into C++ if you have something in blueprints, or how you can start and set up VS Code if you want to start a fresh project. So assuming that you have watched that episode, which means you have your project in C++ now, and now we are going to have a look at the character attributes. So in Gas, we are going to use this thing called gameplay attributes, which is going to help you to create your character's attributes like health, stamina, or other things that you want your character to have in the gameplay. Okay. So for this, as you know, there is in the edit plugins, we have already enabled the gameplay abilities. I would like you to go ahead and enable it, and it will ask you to restart if you are following from this episode, which is absolutely fine. Once you do that, we are going to create a C++ class. So for this, you need to go in Tools, New C++ class. In the All Classes, you are going to search for something called as AttributeSet. So we are going to define a set of attributes for our character, and then we are going to use it with the gas system. So I'll select this attribute set, and this is going to be the basic attributes for any character. It could be an ally, it could be enemy, it could be a player. For example, health. Health is a common attribute for everyone in the game that is a character. So I will call this base, or let's say character base attribute set, and then I'm going to create the class. Make sure you have a copy of your project if you are not good with C++, or if you are doing gas or programming in C++ for the first time, just make sure you always have a backup. Okay, so I'm going to press OK, and I would say that I want to edit the code now. So it's going to open the Visual Studio for me, and there we go. So here you can see we have two files opened up, character attribute set.h and .cpp. And you can locate these files under the source of your project name, and you will find these two files of yours. Okay, cool. Now, before we understand what is this .h and .cpp file, I want you to add something in the dependencies. So if you go in the build.cs, we need to provide some plugins or the modules which are basically required to use gas functionalities in C++. Just like in your editor, you have plugins where you enable the gameplay abilities that allows you to select the functionalities in the blueprints. Similarly, in this C++ code base, you need to select the libraries or modules that you want to use. So I'm going to write the three which I want to use. First is gameplay tasks, then gameplay abilities, and then we have gameplay tags. And make sure everything is in double quotes. Okay, so these are the three modules that we want in the C++ code base. Just like we enable plugins, we add them here. Now once you are done, you are going to right click on your project and look for open folder in File Explorer. You will get in your project folder, you will right click, more options, generate Visual Studio project files. Okay, once you are done, you can close it. And since you modified externally, it will ask you to reload. So just reload all. And once you do that, your modules are installed. And before we go further, we want to make sure that whatever changes we will do here are reflected in the editor. So for this, I want you to close this project of yours and keep this Visual Studio open and click on this play button. And you will see the build will start here. And you see the build is succeeded, and it will load your project again with the live coding enabled, which means whatever you will do in the C++ code, it will be compiled and it will be available for use in the project. So if I look at the project, it's still the same. And now if you go to C++ classes, you will find the C++ class that you created. Now you can use it in the blueprints. And another thing is, in the level map, you will find this live coding option, but if you switch to any other blueprint, you will not find it. So make sure you are always in the level and you click on it, and this will open the terminal or the log window where you can see the compilations. That is a feature that is given by Unreal that is called live coding, which means you code in C++ and things get compiled here. Keep these two windows open. And if accidentally you close it, just click on it again. Great. Coming back to this project in VS Code, every C++ class that you create will have these two files with it. There is a .h, which is a header file, and then there is something called as .c++, which is an implementation file. So if you look at this .h file, which is a header file, you created a class that was inherited from this class. So this is your class name, which you created, and the base class from which you inherited is your attribute set. Okay, so this is your parent class and this is the child class that you created, and this is the header file of it. Great. Now, what is the use of header file? If you go to blueprints and if you go in the character default, for example, and let's say I want to get this, let's say character movement. Okay, now I want to access the get velocity, for example. You see, you are able to access these variables. There are functions like get velocity for nem movement. The Unreal Engine use these header files to read what is present in this class, what this class has to offer, what variables it has, what functions it has, and based on that it gives you the options in the blueprints. Okay, so if you want to understand in a simple words, .h file is storing the template, basically what your class has to offer. Now let's say I want to offer a function that gives me the velocity, so I will declare that function information in the header file right here, and it is going to be present here. Now whatever you declare here or whatever you define here, you will implement its logic in the CPP file. Now I'm not going to start coding right now. First I want you to have a look on the code of Unreal Engine's project just to get a vibe of the C++. If you are fresher or newbie, then I highly recommend you watch this part. So let's have a look at the header files. How do they look? When you do not understand anything or when you are new to something, always look at others' code or the developers who are more experienced than you. Just look at their code to understand or get a vibe and to develop the understanding. So for example, this is the Lyra project. Okay, so let's pick this character, Lyra character.h. Let me close all other tabs and we will look at its CPP file. Okay, .h and .cpp. If you scroll onto the top, there is a struct defined. It is exactly the same. Let me put this in a resize window. The way you define structures in blueprints, this is what is exactly happening here. If you look at this, when you right click and you search for structure, you create a structure and then you define the variables. This is what exactly this code is doing. This is creating a struct class and it is naming it F Lyra replicated acceleration, and it has these three properties of type int. There is a name, there is a name, there is a type, there is a type, and there is a default value, which you see when you create a variable in blueprints. Okay, so this is a struct, we got it. We go ahead, then there is another struct, then we have a boolean, and we have some float variables, we have some integer variables. Okay, so we get it, this is a struct. I'm going to go very simple so that we understand the basic C++ part of the Unreal Engine. Let's have a look. This is where the class declaration has started. So it says that there is a class from this project, and the class that is created is called Lyra character from this parent class that is called a modular character, and then there are three more, which is not something we are going to go into. But you see in this you have some functions created. You have get the Lyra player state, get the player controller, you have get owned gameplay tags, has matching gameplay tags. So you see there are a lot of functions that this class has. There are some public functions, all these are public. then there are some protected functions, then there are some private functions, and there are some private variables. For example, this is a variable. You see T object pointer, it means the object reference. For example, if I go in my player, you see we have created the crosshair variable, and this is a object reference. So this is how you create the object reference variable in C++. So first of all, you tell that it's a object reference, and then you tell what class is this, just the way you do it here. You select the class and then you select the object reference. For example, I do it here, widget, and then you go for object reference. So this is exactly what is happening in this code as well. And then you gave it a name, which is a variable name. Okay. In the class, there are just variables and functions, or to be precise, these are methods that this class has to provide. Some methods, or basically these functions, are accessible by blueprints. Some are accessible only in this class. Some are publicly accessible for every other class, which we are going to go into. But the point is, there are variables and there are methods. Method means functions. And now if I check these functions in the .cpp file, you will find all the implementations like the begin play. Let's have a look here in the character default. You see there is this event begin play. This is exactly the same. So now what it is doing, it is first of all calling the super begin play, which means call the event begin play of the parent class. And who's the parent class? If you go to .h, you see this is your class which you have defined, and this is the parent class. So you want to call its event begin play before you go with the logic that you want to be executed in this one. Example, look at this character default. This is the logic we are doing. What we are doing, we are setting the default gate to walking. We are loading the default animation layer. We are adding a gameplay tag. And now our player, which is inherited from character default, you see we have called the parent begin play, which means first you call all this logic, and once this is done, then go for the player specific logic. For example, the player has a player controller. Not every character has a controller, right? The player will have the player controller, and the crosshair is also for the player, not for the AI enemies, right? So my point is, the same thing you did in the blueprints is also happening in the code. So this super begin play means this parent begin play. You are calling the logic that was present in the parent class before proceeding the logic that was meant for this specific class. So that's a simple explanation of this. Now you see there are a lot of functions that has been implemented. For example, if you call get Lyra player controller function, it is going to go into the C++ file, the compiler, and it is going to execute this code. Okay, the header file was just to give you options, and C++ take care of the implementation. So if you call any function or access any variable's value, it is going to be catched from C++ file. Okay, so that is the gist of it. So going back to our characters attribute set we created. So you see these are some basic headers. Then you tell the compiler that we want to create a class, and this is the information that class from this project, which is first third person game API, and this is the class I want to create, and it is derived from the attribute set. Now I have many viewers who are completely into blueprints and are not ready to go into C++. Now for all those people, I want you to just think and act like a bank. Be a Swiss bank for that matter. Which means first you should follow the protocols. Second, you should respect the boundaries. Third, don't be afraid to create new policies or rules. And it is okay to have a lot of lines of code. It's absolutely fine. If you follow these three principles every time you are writing the code, you will be good. Now you might be wondering, what are these protocols or boundaries or policies or rules I'm talking about? Let's take an example. Let's say there is a bank. Okay. Now you see in every bank, there are people, there are customers, there are employees, there are resources, there are bank accounts, there are loans. A lot of things are going into the bank. Let's consider the example of an account. Okay. You created a bank account class. This class holds information about account. which means there are variables that stores the name, the mobile, the address, the wallet balance, or basically the account balance, right? These are the information that bank account holds. Of course, there are more, but I'm considering these four. Now, this is a header file, okay? This is the structure of our bank, that whenever we open a bank account, these are the information we need from our customer. I hope you agree with me on this, right? So now let's say if a customer or if an employee or if a clerk or a loan department, for that matter, any entity in your bank want to access this bank account and want to read its information, it could be anyone, customer, employee, clerk, or any other entity for that matter. Direct access, meaning reading the variables directly, is strictly prohibited. If you can follow this principle in your entire programming duration, trust me, you are going to love it. This is the principle of object-oriented programming, that you should never, never, ever access the variables directly. So how do we read that? We create functions. For every single variable, you have to create a get and a set function, which means if you want to get name, you create a function called get holder name. If you want to update the holder's name, if you want to update their mobile, if you want to update their address, you create another function for that just to update the value. But you never ever do it directly. You always call the bank account function to update any of its variables. Okay. And you see there are 4 variables. I have created 4 functions, which is the right way. The external blueprints, classes, whatever you want to call them, if you are a beginner, you always call the functions of that class to access any value or to update any value, or if you want to send them any event or any information, you always call the functions. These are like phone numbers. You call them and they do the job for you. You do not do it. A customer should not be allowed to update anything directly. Now, don't go exactly by the words I'm saying. Like you will say, oh, the customer is going on a website and he's updating the values. That's fine. That is the interface. But in the background, it's not the customer that is updating. It's the function that is going to update the data inside it. The customer is just going to provide the information. And where is that information? When you call the functions, you provide the inputs. And that is what we call getters and setters. Getters just get the value for you. Setters set the data inside those variables, and every variable will have one getter and one setter, which means function to get a value and function to set the value. Now, why am I emphasizing on this so much? Let's say your bank account class or the functionalities or the information, it goes big and big. That means you will have tens or 15s or 20 or hundreds of variables. You do not want that. So you decided to change the structure, which means you said, I will just create one variable that is info, which is a structure. And in that, I will store the name, mobile, address. That's it. And then there will be a second variable that will hold the account balance or the wallet balance. Now you see, you have changed. You removed these 3 variables and you used a structure instead. The struct type. I hope you guys remember. We created a struct type and this is the variable and we stored all these 3 information here. Now, if you are accessing everything directly, you have to check every blueprint or every class and correct it over there that use this struct and then access the name, mobile, address if you want to. Right? That's a big pain. You don't know. There are a lot of classes. Your game goes big. You do not know where you are using what. Even if you do find references, it's going to take a lot of time. That is not something we want. So for this, if you would have used functions, you just have to modify the code here. So if you are making a change in your bank account class, which is in the variables, you just update their functions. No one needs to know what is happening inside your class. They are just calling this function, period, nothing else. So in the programming, we call this data structure and algorithms. Data structure means how you structure your information, how you store it. And then there are algorithms, which is basically the methods or functions or your logic basically, which is going to manipulate that data. So your functions remain the same. Your users that are using this data in any format are going to stay clean, they are going to stay normal, they are not going to be affected by the changes you do, because you have to admit that you are not going to be achieving the perfect structure for your data in the first attempt. So always follow this principle that whenever you create a variable, or no matter how many variables you create, you always set up two functions. One is to get the value, one is to set the value. So this is what I was saying, that you should follow the protocols. So it is not like that you should not be allowed to access variables at all. No, in some cases it is required. But in that case also, there is a privilege that the class holds. For example, if there is a safe in the bank, not everyone can access it. There is a lot of money inside it. There are only some security people and some top authorities that can access the vault of the bank, but not the clerks or the employees can access it, right? So your variables are like that bank vault, okay? Some vaults are accessible for all, some are accessible for the members of that class, some are accessible for the child classes you derive them. So this is what I meant when I say boundaries. Don't worry, don't buy hard, just remember these three rules. As we code in Gas and in C++, you will understand what I'm trying to say. And when I say don't be afraid to create new policies or rules, I meant that you should feel free to create as many as functions you want, because functions keep things modular. Okay, so it's okay to have a lot of code when you are writing. So if you were in blueprints normal, you would have just created the health variable and then you would have manipulated it by subtracting or adding the numbers. So we are going to create a variable. But here you need to tell Unreal that whether this variable is publicly accessible for all, or this is a private variable, which means only the functions of this class can access it. No other external class will be able to access it. Or is it a protected variable, which means the child classes can also access it. I suggest you read about them, or as we go along coding, I'll explain you all these access specifiers. So we will say that it is accessible for everyone. That's why we say put this under public tag. So now whatever we define after this public will be available to all the classes. So first thing, we define the type of variable, that is f gameplay attribute data, and the variable name is health. Now, if you want to discover it in blueprints, you have to tell Unreal that this is a property, all caps, and it is allowed to be edited anywhere. That means everywhere. And you should be able to read and write it from the blueprints. And I want to assign it a category, and I would like to call it base attributes. So when I say category here, do you guys remember the state tree task? We used to put the variables in categories just to organize them and group them properly. If you want another example, in animation blueprint ABP base, remember we created these categories, acceleration data, and all the variables related to this one is in this category. Then there is a velocity data. If you select this variable, you will see the category it has been assigned and it gets grouped. So that is what exactly we did here, because health is a basic attribute that every character will have, but stamina is something that a player will have. So you want to organize your attributes in a proper way, so use categories. So it's the same as blueprint. Now, like I said, object-oriented principles, the protocol says you should have getters and setters functions available so that you can update the values, and Gas heavily relies on that principle. Why I'm saying that is because the Gas has gameplay effects, gameplay abilities, where you just manipulate the tag and you provide the information and then it updates the variables. It needs to know the functions so that it can update the values. It doesn't go there in the class or in the object basically and update the value directly. You have to create the functions for the Gas system. So for this Gas system, we are going to create these functions which will allow it to update the value or get the value or initialize the value of this variable. So I'm going to use something called as gameplay attribute property getter. So this will allow Gas to get this variable from this class. So the class name is uCharacter base attribute set. You see this highlighter, just press tab and it will autocomplete. Don't press enter. If you want to press enter, then you have to select it like this via your arrow key and then you can press enter. So this is one function. Now the second one is your getter, which is the value getter. So this will allow you to get the value. Now when you hover or you write, you can see what are the inputs this function requires. So it needs the property name, which is the health. Then you want to give a function to update the value. So we give gameplay attribute setter and the property is health. Then there is a third one, which is initializing, which I will tell you in a minute. So you go for value initter and then you go for health. Okay. So these are the four things that gas needs to know about this gameplay attribute data variable so that it can manipulate its values. You can copy this entire 5 lines or 6 lines and do the same for max health. Okay, so let's copy this. Okay, so there is a health, then there is a max health, and both are part of the base attributes. Where is this coming from? Do you remember Resident Evil 4? When you start the game, you just have 3 or 4 blocks of health. Then you have to consume the herbs to increase this up to this point. Or if you are in Souls games, you have to collect certain items or go to merchant or something to increase your max health. So that is the reason I created a health and a max possible health. Now we understand each other. Now where is this initter coming from? Once the character acquire these attributes, you want to initialize them with the default values when the game opens. And of course you are going to save and load them back. But the idea is you are going to initialize them when the game loads, when your character loads with these attributes. So if you want to do something at the initial point, you call the constructor of the class. Where is this constructor coming from? Do you guys remember the construction script? If you are following the series, the level design series, remember this procedural building algorithm, the actor building exterior? You put this in the level and it calls the construction script. Every actor or class has a construction script, remember? Construction script run as soon as you create an instance of this particular class, or for that matter, any class. So let's say this is my building exterior actor, which can make the exterior walls of the building. As soon as I place in the level editor, it created an object and it ran its construction script. Event begin play runs when you play the game. Construction script runs as soon as you create an instance. So as soon as you dragged it into the level editor, you created an instance, and you can see in the outliner, you have building exterior and other instances of these classes. So they run their construction script. And that's what we are going to do here. So right below the public, we define the construction script. So to do it in the C++ code, you name the class as it is with the parenthesis. And this will call the construction script. Now I want to do something. What I want to do is set the health and the max health. So you go in C++ and this is where you implement it. So to implement it, you have to first tell the class name, which is the uCharacter base attribute set. And then you do double colon and you tell what function are you implementing. So I'm implementing the construction script, which is by default called with the same name of the class. So I put this exactly here. And then I call this. Boom. Now you want to set the initial value of health and max health. And you created these getters, setters, and initters. The functions are created. Now if you search for init health, yeah, you see there is a function for you. Now you can initialize the value. Let's say initially you will get from 50 and initialize the max health. You get it, let's say 100. You have a max health of 100. And do not forget to put semicolons. Boom. So you initialize your variables right when this attribute set is loaded in your character. And as soon as your character loads, the construction script or the constructor here will run and will set these values in these variables. Do you want to check it out? Just save all, go to your project, and if you click on this button, it will open that live coding pop-up again, and you can see there is an error. So I'll go and I see there is an error. So this functionality is not coming in these libraries. So they are basically coming from AbilitySystemComponent. So we have to include its header file so that compiler or the Unreal Engine knows that this is coming from there. So it will look into its header file and it will check the list. So I'll say ability system component.h file and make sure all the .h files are above the dot generated files. Okay, the dot generated .h should be always at last. Now you can see the errors are gone. I can go back and I can click on this again and it will manually recompile again and the build will be done again, and you see the build is successful. Okay, so now to use these attributes in my character. So if you are following the series, as you all are aware that character default is our base class right now, and then from there you have player and AI default, then you have AI characters like SWAT soldier. We are going to create another character class which will be the base character from where we will inherit this character default. Right now you see if you open the character default under the class settings, it is derived from the character. Instead, we will change this class to our base class where we will put the gas code as well. So what I'm going to do, I'm going to go in tools, new C++ class, and I'll select this character and I will call this base character and I'll create this class. Once you do that, you will get a file modification detected pop-up. It's okay, just reload all because you created a class from the editor, not from the code base. As you can see, there is a base character.cpp and base character.h. Okay, cool. Now you can see the base character h already has some functions for you. There is a base character, which is the construction script that will be called. Then there is a begin play, which is protected. Protected means this class, the base character, and the child classes that you are going to derive, which is character default in our case, we are going to derive it from this. They can access this begin play. Remember this event begin play in the character default, which was accessible for you in the BP player because it was derived from the character default. So this player is a child of character default, so it can call this function because this is a protected function. If anyone else try to call this begin play, it will not work. It will not even list. So public means anyone can call it. Any actor can access your player and it can call this function. Protected means only the child classes and the class itself can call it. And private means only this class can call it. And when I say this class can call it, that means the functions that are created in this class can call this function, which are private. Okay, great. So you can repeat these access specifiers. It's not like that you have to specify once and you have to list everything in there. No, you can always shift and change. So I'll go back to editor. I'll go to level 1. I'll click on this and it will compile, which will be just fine. And if you don't like the errors, just reopen the editor, but then you have to reopen the project as well. So I'm going to do that. I'm going to close this and I'm going to open this .sln file again. And I'm going to play. And once your build is succeeded, you will find your errors be gone and your game is back open. You can click on this. The live coding is also here. Great. Don't worry. We will not be creating classes via editor every time. I just wanted to show you in case you want to do that. Great. So you have some header prepared by Unreal. Let's do what we have already done in C++ again. I am doing this very, very intentionally. If you are following the series, if you go to character default, you will see that you have already added the ability system from this components tab. But if you are creating your character or the base character or the parent character class into C++, how you are going to add these components? You know how to make variables, but you do not know how to create components. Actually, it's same. So if you go back under the public, you will say you want to create an AbilitySystemComponent. So the class for that is AbilitySystemComponent, which will not appear, which is okay. Put a star. And then I'll say AbilitySystemComponent. This is the name of the variable and this is the class. And to get this class, you have to include its header file. Now see, there are two ways to include this information. We have to tell Unreal that there is this class that we want to use. But now there are two things. Do you want to access anything from inside that class? If yes, then you include it. But if you just want to tell Unreal, hey, there is a class, I don't want to import its all header files. That means I don't want to know what is inside there. I just want to tell you that this class exists. What you can do is just add class UAbilitySystemComponent right here. Okay, I made an error. It should be AbilitySystemComponent. And if you save, you see the error is gone. Now, why I did that? See, in the attribute.sh, you included this ability system component because you wanted to access certain functionalities inside it, right? So if you want to access some functions or variables inside this class from this class, then you include it. But if you just want to tell that, hey, I want to use this class and there's nothing specific I want to use from inside, I just want to use its class reference, you can just tell it like this. You do not need to load the entire list of functions and variables into this. So this is how you optimize your code. Okay, so there are two ways to import something from other class. One is you just tell Unreal that believe that this class exists. Another, you include that class so that you can access something from inside it. Great. So we created this, but we also wanted to be listed in the Unreal Engine's editor. So I will say U property. You will always define this on top of the variable. We want to say it should be visible everywhere. That means anywhere. And in blueprint, I only want it to be read only. That means you cannot edit it. If you want to edit, you have to come back to the visual code base. What do I mean by that? If you go to editor and you see this is the interaction manager, if you edit, then you go into its class which is present in the blueprints, because this is the actor component that we created in the editor. But when you do this, that means you cannot edit it via the editor. You have to come here in the code base. So that's what I want. I do not want anyone to touch my ability system component from editor. I want them to come back to the code base. And I want to assign a category. I would like to call this abilities. Okay. So this is one variable or component that I want to have. Okay, that is all right. You just told that you have this, but you haven't initialized it, right? So to initialize it, what I told you, call the constructor. So this is the class name. Under the public, you called it, but is it implemented? Let's check the .cpp. You see there is this constructor being called, and you see there are other functions being implemented, which you have listed in the header. There's a begin play. You see, first you name the class, double colon, and then you call the function. And what that function is going to return is going to be present at the start. We are going to go into it, don't worry. So in the construction script or the constructor, we would like to create this ability system component and we want to store its value. So we have to create its object and we want to save it in the ability system component variable. So equals to create default sub object. Then you have to tell, okay, you want to create an object. It is similar to construct object from class. You tell it class and then it will give you this object. So we are going to do the same thing here. You call the construct object from class and the class is UAbilitySystemComponent. And then you press tab. This is the class. And then I would like to give it a name. I'll just call the same name. So I'll give it AbilitySystemComponent. And then I'm going to put a semicolon. Okay. So let's save it. Go to player. And let's compile this. Come to character default. Let's go to level map. Open our live coding. And you see now it's throwing the error because we are trying to create a ability system component. Now we need to include its header file because we want to create the object. So we'll say hash include ability system component.h header file. Okay. As soon as you do that, you can save, you can come back here. And if you click on it again, you see the build is succeeded. All right. Now you can always check in C++, you have the base character and the character attribute set. So if you are someone who is following the series, then you can go to character default. And if you are someone who is just doing it for fun or doing it from scratch or having your own character class, like third person character, just go in class settings, change the parent class to the base character. As soon as I do that, I will have an ability system component here. You see, I got ability system component, which is something I created in C++. And if I have to edit, I have to go in the C++ code base. So I'm going to delete this ability system because now we are going to use this one. So let's delete it. If I compile, there is no error, but in the player you will have. So compile and you got the errors. Let's replace them. You can see it is also replaced here. So let's get our ability system component, get it here as well. And then we compile. So everything is good. you save all. So you see, it is easy. You got your base character as your parent class and you acquired its variables or components or functions. Now let's add the attributes, shall we? We go back to public. I want to say this is a variable and I do not want to give it any kind of privilege. This is something internal. Now first you have to tell the type. So let's get the type, this one, character base attribute set star, and I want to name this variable base attribute set semicolon. Now you are using a class. I do not want anything from inside because in this header file I'm not using any function of this class. I just want to tell Unreal that it exists. Just declare it like this by class and tell Unreal that is exist, period. Great. Now you have to initialize it. Go back to CPP. Do one thing at a time. Don't do everything all at once in header, then come back to C++. Just do back and forth. It will make you feel good and comfortable with the code base. So right after I'm done with the ability system, I will assign the value to the attribute set. So I'll get this variable. I'll copy it. The value is create the default sub object class. You get the class name from here and you paste it. And then you give it a name. I want to give it the same name that I have here. Now, since you are using the class, you have to include its header in the C++ implementation file. So include character base attribute set.h file. Once you do that, you are good, and don't forget to put the semicolon. And now, if this object creation is successful, that means if my ability system component is valid and base attribute set is also valid, this is same as the is valid node, then grant these attributes to my character's ability system so that it can have it. So for that, I'm going to go ability system component, and then I want to access its function. So we do arrow add attribute set sub object, and that object is base attribute set, period. Once you do that, it will be available for you. You can come back to character default and let's go to level map and hit the compile again. So let's say I delete this test example that I was doing. I will go into player, and what I will do, I will go for keyboard J. Okay, when I press J, I want to get the health. Okay, so this is my character. I want to get the health. So that means I need to have a function that can give me the health value, because right now it doesn't exist. So what I will do, I'll go in the base characters.h file and I'll say in this place, these are the functions, these are the variables. So I'll say it's a public function. It will give me my health. So health means number. So I'll say float value type, and I'll say the function name is get health. So if you call this function, this is going to give you the health, which is of floats, and then we put a constant. Now people will wonder, what is this const? Remember, we were creating pure functions. Let's go in content generic. I'm trying to relate with the things that I've shown in the series. This is a pure function. You remember, you mark these functions pure. Just like that, you are not modifying anything in this function because you are just going to get the value and you are going to return it. So it is not modifying anything externally. So make this as a pure function. So that's the reason I wrote const, so that you don't have those execution pins, which means you can call like this, not like this. These pins will not be there. Okay, I'll show you. Let's save. And I want this function to be callable by the blueprints. So I'll say U function, because this is a function, and I'll say it's blueprint callable. That means you can call it in blueprints. Okay, and save it. I have to implement it. So how do we implement? First, what is the type of this function? That is float. So I'll say float, then the class name, that is our base character. Then I want to implement a function which is called get health. And whenever someone calls it, get my base attribute set variable where the health is present, and I will call get health function. Once I do that, I'm going to return it. Oh, by the way, you also have to write const because we wrote constant here. So before we access it, we have to make sure that base attribute set is valid, because if it is not valid, then we are not going to call it. So if it is not valid, then just return 0.0f. That means 0 health. Go back to your player and get health, and let's go to third person map. I'm going to hit the live coding again, and the build is succeeded. I'll go to my player and I will search for get health. You can see the function is present and it is from the base character, which is the parent class, so we can access it and I can print it. Oh, it should be in the string, sorry. If I play, press J, you see it says 50. That is our health. All right. So this is how you set up the attributes and that's how you access it. So that's it for this video. I hope you enjoyed it, and we have crossed the time limit of this episode, so I cannot continue in this one, but this is how you create the attributes for your characters, and you can create more than one attributes and you can create more than one attribute set. This is a base attribute set. You can create a magic attribute set. You can create something else. Basically, you can create multiple attribute set for your player or for your characters or for your enemies. We will do that in this series. However, there is second thing that you should know, like right now you are using this get health function to get the value, but you are not going to call this every second or every tick in other components. Like for example, your UI widget where you are showing the health count on the user screen, you cannot call get health every time. You want to know when the health changes so that they can also update their values. So in the next episode, I'm going to show you how you can use gameplay effects from the gas to update these attributes, because remember, gameplay attributes are part of the gas system, and the protocol says that the attributes have to be updated by the gameplay effects, not by any other class or for that matter actors. Basically, they cannot update it. They will just apply the effect and then the values will be updated in background by the gas system. So when it comes to gameplay attributes, we will use gameplay effects for damage and for heal as well. So for example, if a character or an enemy is hitting you, they are going to apply a gameplay effect that is damage, which is going to reduce the health by certain numbers. And then there is a medikit or herb like Resident Evil 4. You are going to consume it and it's going to apply a heal gameplay effect, which is going to increase your health number. And when this thing happens, when the number changes, all the people, that means all the classes or entities that are listening for that value, will get updated as well. So the idea is you communicate through events and not check every tick. Okay, so in the next episode, we are going to dive into gameplay effects and we are going to extend what we did a little more so that you can understand how we use these attributes in the blueprints. Okay, so I hope this video was helpful for you guys, and this is the first C++ video, so let me know your comments, suggestions and thoughts, and if there is anything you want me to improve in the video, do let me know in the comments, and I will see you in the next episode. And if you like my work and you want to support me, then the Patreon link is in description. Check out the perks and do reach out to me on Discord before buying any membership. So till then, take care. I'll see you in the next episode. Bye.